Hey everybody, my name is Nick and here is another Arduino project. So what we have in front of you is an Arduino car controlled by Bluetooth signals sent from this phone. And the cool thing about this is that you might notice that there's only forward and backward, but you actually steer by tilting the phone, and then you have your forward, backward controls and all like that. But yeah, so this was a fun project that's actually special because I did it with my sister, and so we both got to work on it, and it was nice. So now I can show you the wiring. Okay, so here are the key components to this build. So first, right here, we have the HC06 Bluetooth module. You can have the HC05, doesn't really make a difference. And then second of all, we have the motor shield. And then the motor shield is basically just an easier way to control the motors. So first things first, we'll talk about this. So it has a power and a ground, and those go just into the Arduino pins because this motor shield presses on top of the Arduino and on top of all the pins. So you want to make sure that you have kind of a stranded wire, not solid core, so you can press down the pins on top of it. So as I was saying, power goes into 5 volts in Arduino, ground goes into the ground of the Arduino. I'm just drawing it into the motor shield because I'm representing that the Arduino is underneath it. So then we have the transmit and receive of the HC06, and it actually uses the serial ports on the Arduino, which is why they have the arrows and everything marking them like that. So the transmit goes into pin 0 of the Arduino, which is also the RX pin, and then receive on the HC06 goes to pin number 1 on the Arduino, which is the transmit or the TX pin on the Arduino. Then right up here, that is our servo control for the steering effect of the car. And the reason why I plug it into the board and not smash the wires and plug it directly into the Arduino is because there's 2 servo pin sets on this board, and the one I'm using actually connects directly to pin 10, so I can just write that in the code itself. Then right here we have plus and ground, and that's the block for the motor shield, and so all you have to do is just screw in 2 wires from a battery pack for plus and minus, and that will actually also power the Arduino, so you don't need 2 power sources. Then here we have motor 3 and motor 4. So motor 3 has a negative and a positive. The reason why I'm not writing it down on there is because it can depending how you put your motors in, it can be switched around either way, and then you just have to mess around with the forward backward settings on your code. But for me, it's a certain way, and for you guys it'll be another way. So yeah, so you want to plug in a power and a ground to motor 3, and then power and a ground to motor 4, and that is pretty much it to the wiring of this build. So most of the stuff with the motors gets done on here, but you'd have to send the signals by the Arduino, and we will get to that into the code. See ya. Okay, so here is the code for the Bluetooth car. Now I also have code for the app, but I will get into that later in the video. But for right now, I'll just give a general overview of the code that's going on in here. So the first things, sorry about that, the first stuff up here, these are just a bunch of files that you have to include. So you include the software serial and servo, and if I'm correct, they're both built into the Arduino IDE. And then you have to include a custom library called afmotor.h, and that is the motor that goes, or that's the, that's the library that goes along with your Bluetooth, or with the motor shield that you use for the car. Then right here we initialize a few things. So we set servo val to 1500 because that's the center position, and then we set mode to 0, and that's for my forward, backward, or stationary. So 0 is stationary, and then let's see, 2 is forward and 1 is backwards. Yeah. So after that, we basically set up both of the motors for the AF motor with the special commands that they want. So you just give the key thing AF motor DC or AF DC motor, then you say then you give it a name, and then you set which motor block you put it on, and then if it's on the back you set 348, 348, and then if it's in the front you just do 1 2 because it's block 1 and 2. Then after that, you have to set up your Bluetooth pins. So because it's going through the serial, it uses it uses the library called software serial, and then you just name it Bluetooth, and then here you have your 2 Bluetooth pins, and so you do your transmitter and your receiver pin like that. So the Bluetooth transmitter is 0 and receiver is 1. Then right here, this is a bunch of messy stuff to set up the Bluetooth kind of connection with the Arduino and stuff, and with the phone, and to get it all running. And it doesn't look that pretty, but it works for me at least, so I hope that will for you. Then after that, we have the loop, and all it does is it sees if a Bluetooth reading is available, then it sets an integer to that value. Then it also sets a character to the value of high, and that's so I can check whether I have sent an F, S, or B, which I will get into on the phone side, because I needed to somehow tell it to go forward, backward, or stop. And then it basically just, if that is the case, then for debugging I just have that there. Then we have if it is F, then it goes to mode 1 to go forward, S, then it's mode 0, and B, it's mode 2. After that, we have an else, just to say if it's not equal to any one of these values, then we just print out the regular integer value, and then we make sure if that is less than 100, or actually yeah, less than 100, because after 255 it drops off back to 0 because it's only sending 1 byte at a time, because I have very limited control in the app inventor, just because it's how it is. And so then just when it drops off after 100, then I just add 255 on to compensate for that. Then all we have here is a servo val, and then we change servo val, which we just defined up here, and we change that to the map of the variable high, and then it's minimum and maximum, and then the minimum and maximum of the servo. Then right here we have servo then we just write to the servo val. Then right here we check what mode it is, and then if it's mode 0, then it sets the speed to 0. If it's mode 2, oh whoops, sorry, I got that wrong. If it's mode 2, then it actually sets it forward. In mode 1, it sets it backward. The reason why it might be mixed up for you guys, and it might be different from mine, is because you can plug in the wires, the plus and minus for the motor, either way on the blocks. So depending how you do that, you have to change it on the code side. But that's not a big deal. It's pretty simple. You just switch the values around. But yeah, so that's pretty much it for the Arduino code. So now I will show you the App Inventor app code. Bye. Okay, so here is the app part of this whole project. So I am using a program called MIT App Inventor. You might have heard it, maybe you're not, but it's a great program that just quickly allows you to assemble an app and then directly test it on your phone, and then once you're happy with it, you can just download it in an APK file. So it's a very nice app that enabled me to do this project. So right here, this is just your screen. This is completely cosmetics, and you can do whatever you like here, as long as you have your forward and backward buttons and your Bluetooth list. That's pretty much all you need. Now there also are some non-visible components here called Bluetooth Client 1, Orientation Sensor 1, and Clock. And I'll get into those a bit later. But yeah, so that's pretty much it for screen 1. Now we'll go into the blocks that run the app. So, starting off here with the orientation sensor, and this is one of those hidden components. And one thing you have to make sure is that when you're looking for like when orientation sensor 1 is changed, it's not anywhere in these regular blocks up here. You actually have to click on orientation sensor 1 to get those special blocks. And that annoyed me for quite a while when I could not find that block, but now I did, and I was able to make this app. So, when orientation sensor 1 is changed, what we do is we send a 1-byte number, and we round that number and get roll. So it basically gets the roll position of the phone, and it rounds it, and then it sends it as a 1-byte number. And the reason why I have to round it is because if I didn't round it, it would be this insanely long decimal number, and the Bluetooth client wouldn't allow me to send it. So that's why you need to round it. Now, over here with the clock, so we do one clock timer, then so what we do in here is we check if the Bluetooth client is connected, and if so, then we enable the orientation sensor, and then we turn the text or the label to text to connected, and then we set the color to blue, and then we check if it's not connected, or if the Bluetooth client has it connected, then we set it to false, the orientation sensor enabled, and then we set label to text to not connected, and then the text color to red. Now over here with the list picker, so we have before picking, it just basically sets the elements to Bluetooth client, or to the available addresses that are out there that the Bluetooth is actually picking up, and so it sets those on the list. And now this part right here you don't need. I just had it there for testing purposes. But yeah, so after you've picked something, it calls the Bluetooth address connecting, or it wants to connect to it, and then and the address it connects to is the list picker selection. And then after that, it sets the elements back to Bluetooth address and names. So that's pretty much it for the connecting and the steering, but how do we actually make it drive? So that's what we do with the button. So what we have is when the button 1 is touched down, we actually have to momentarily pause the orientation sensor, because otherwise we could not get our Bluetooth signal through. So what we do is we send the text, and we send text F, and as if you remember, in the Arduino IDE portion, it actually checks for the specific letters, and then it will set the mode to make it go forward or backwards. So that's why we're sending the text. And then after we've sent it, we enable the orientation sensor to true. Then same when we touch up, we do it false, send our S, and then true. Or then we enable the orientation sensor back to true. After that, it's basically the same exact thing for button 2, except it sends B for backwards instead of F. And that's pretty much it for this project. So yeah, it's a really cool project. I hope you guys like it. I hope I was helpful in guiding you on your way there, and I hope you enjoyed. See ya!